Hi Chenchen, can you please show me how to use disco clearing for isolated organs?
Sure, at the moment we have two options. Firstly, we can use the passive version for uDISCO to boost the sample and then use uDISCO to clear the sample and imaging. But this is a straightforward way, which is the uDISCO protocol. If you have a transgenic mouse line expressing the fluorescent proteins, it's the best way to preserve the signal with uDISCO and directly clear with uDISCO and image afterwards. So today I'm going to show you how to directly use uDISCO to clear the sample and for imaging.
Okay, great.
So at the moment, I'm focusing on this transgenic mouse line from Taiwan GFPM. Here the mouse brain, that's my major target to clear and image. So firstly, we put it into the Eppendorf. This is a 5 ml Eppendorf, which is resistant to the clearing solutions. First of all, we need to put the labeling. For example, mark it carefully. And to prevent the marker to be washed out by the organic solvent, we will treat the sample. We put a transparent tape. For example, like this. Yeah, this will protect your marker. And then we drop our sample in the Eppendorf. And then use a plastic pipette to drop the solutions started from 50% of tertbutanol as dehydration solutions. Try to fill the Eppendorf. Like this. Yes. So now we have the sample, and then we move to the thermal shaker for passive shaking and for clearing. Now we have our sample on the thermal shaker. We cover it with a cover, and then set the degree as 35 degree, and then we start shaking. Yeah, each step will take 4 to 10 hours, depending on the size of your sample. For example, here we have a dissected whole brain. We put it longer for 10 hours for each step. And if we have a half brain or short or smaller tissue, you can go up to 4 hours per step. And for the gradient of the concentration of tertbutanol, we now use 50%, 70%, 90%, and 100%. We repeat 100% twice overnight, and then we treat the DCM for 1 to 2 hours. Then we put them in the BAP-D for a solution for final refractive matching. And then you will get your sample cleared within 3 to 4 days.
Thank you, great. Can you also give me some more tips on general organ clearing?
Sure, that's a good question. For uDISCO, we prefer to take some sample with a high expression of the fluorescent proteins. For example, you have a Taiwan GFP line mouse, then it's perfect for uDISCO. But you have a 6CL1 GFP line labeling the microglia. Sometimes the tiny processes, we cannot visualize them with uDISCO. In this case, yeah, for example, the promoter is not as strong as what we expected. We need to switch it to uDISCO passive boosting protocol. As we know that we treat the sample with nanobody, therefore the signal is also amplified, as well as the imaging channel is shifted to the far red channel, which will give you the less background. This will give us the best contrast as much as we can. So, yeah.
So could you also explain me what the advantages are for uDISCO?
Sure. As you know that we use nanobody to boost the sample. They're conjugated with very stable dyes and very bright dyes. And then we can stabilize the signal permanently. For example, nowadays we can image the sample even after almost 2 years after the staining. But the signal level is not declined, it's stabilized. And due to this amplification as well as the stabilization, we can treat multiple types of samples with a very weak expression of the signal, and we can still see them nicely. And we also have a wide range of collaboration from different labs from all over the world. And this protocol works perfectly for every application right now so far.
Cool.
Yeah.